Good morning everyone. Welcome to the discussion of the discrete mathematical structures, wherein discrete mathematics is one of the most rapidly growing areas of modern mathematics, which has wide variety of applications in science, engineering and commerce. This subject provides fundamental mathematical background needed in computer education, and all major universities around the globe have recommended one or more courses on this subject in the computer science curriculum. When you consider the discrete mathematical structures, the first things that comes into our mind is the set theory. So what do you mean by set? What are the methods for the calculations involved in it? What are the operations of the sets? Other things we are going to discuss in this topic called as set theory. So first and foremost, we are going to learn that what do you mean by set? The idea of a set is fundamental in the study of mathematical structures. Strictly speaking, a set is an undefined term. Intuitively, a set is nothing but a collection of objects of any kind which are collected together, perhaps because of some property they have in common. If you consider an example, collection of numbers used for counting, collection of all paintings of an artist. A set is determined only when we know definitely what object it contains. There must be no ambiguity or doubt in this regard. For example, the collection of all tall boys in a college does not define a set, because there will be some doubt about as to which boys are regarded as tall. For this reason, objects of a set are required to be well defined. By this we mean that given an object, it must be possible for us to decide whether the object belongs to the collection or not. Thus, if we speak of the collection of all boys in college who are above 170 centimeters, then we are actually speaking a set, because without any ambiguity we can say whether a given boy is in the set or out. Mainly the objects of set are required to be well defined. And next, moving on to that, objects which make up a set are called as the members or elements. If the number of elements in a set is called finite set, if the number of elements are in the set is finite, then it is called as finite set. Sets having infinitely many elements are called infinite sets, and sets having only one single element or only one element is called as singleton set. Continuing, for describing a set, there are two methods. One is tabulation method and another one is the rule method. So what do you mean by the tabulation method? All elements of set are written down within braces, that is flower brackets. If there are too many elements, the first few elements are written down in such a way as to indicate clearly what others are. But in case of rule method, we specify that the set by stating a characteristic property which all elements of set possess and which no other object possesses. Example, if S is a set of positive odd integer, then S can be described as shown below. The first one represents the tabulation method, that is S is equal to, that is inside the flower braces, 1, 3, 5, 7, so on. That is, it is nothing but the set of positive odd integer. It is written in the form of a tabulation method. But when it comes to the rule method, S is equal to x slash x is a positive odd integer. That is, the second description is read as S is a set of elements x such that x is a positive odd integer. The first description is read as S is the set consisting of the elements 1, 3, 5, 7. So this is the difference between the tabulation method and the rule method. But when we come across a singleton set, that is singleton set consisting of a element A, is described by the tabulation method and is denoted by, that is single element A inside the flower brackets. This is how we are going to define the singleton set or denote the singleton set. Thank you.